Welcome to the Heat Treat Podcast, sponsored by Matza, Creo, and Super Systems.
Welcome to a new edition of the Heat Treat Podcast. Hello, everybody, and welcome to today's episode. We have Bob Fincken, Manager of Sales at Super Systems, here with us. Bob is an expert in furnace controls, and today we'll explore the history and evolution of furnace controls and what's new in the field and how these controls are shaping the future of the heat treatment. Bob, welcome. How's it going?
It's going great. Great. It's good to be here, Carlos. Thanks for inviting me.
No worries. It's been a pleasure. And so, Bob, can you give us an introduction about your career, the company you work with, which is SSI Super System, which is a titan in the industry, and a little bit of background, please?
Sure. Always been in the Ohio region here in the U.S. And after I got out of college, I ended up working short term for a company called Escort, which is a microwave type company that does radar detectors. From there, went on to work for a heat treater, which is interesting. Cincinnati Steel Treating is where I started my career. And there I ended up working, kind of designing circuit boards and things like that for the heat treating industry. And I had some people in my life that kind of moved me through this part of my life. You know, one of the guys here is still working for SSI. His name is Don Riemenschneider. He's our engineer here. He writes a lot of code. And I actually worked with and for Dan McCurdy for a while. You know, we know Dan from Body Coat. Marathon Monitors came on board and bought the division from Cincinnati Steel Treating. Ended up working for Bill Thompson. So I had a bit of a stint with Marathon for quite a while. I left there, went to Eurotherm, worked there for about 10 years. After that, I missed being specific to the heat treat industry because Eurotherm I covered a lot, you know, medical, plastics, things like that. So I came back and joined SSI with Steve Thompson and all the other guys here back in about 2006, somewhere around there. But yeah, so I've always been involved in the process of controls. My expertise has always been in early stages, was doing circuit board design. Moved on from there to do AutoCAD work, then was support out in the field for making these things work, actually starting up furnaces, things like that. And then now I'm a VP of sales here at SSI and enjoying my career and looking forward to what happens next. We got a lot of young guys coming in, and I'm trying to make sure that they have a path to follow.
And also on the soft side, Bob is a car enthusiastic and a racing enthusiastic as well. So if you ever want to talk about racings or cars, muscle American cars, Bob is the guy to go. So if you meet him around and you're a car enthusiastic, this is the guy to go and talk to. But now let's get back to controls. So long career on furnace controls, but can you give us a brief overview of how furnace controls have evolved over the years? What were some of the first type of controls, and what drove the development or more advanced systems? It was relay control, and it was on and off solenoid valves. Maybe it was just a valve. But right now, the matrix, which is the latest control of SSI, is pretty advanced. But, you know, for the audience, can you give us a little bit brief history of how this happened through the years? I know that electronics had to do a lot of it back in the 80s, in the 90s, but if you could just give us a brief background, since you lived it in first row.
Yes, yeah. So back when I first started looking at furnaces more closely and evaluating what types of controls they may need, it kind of dates myself, but there were a number of systems that really just controlled by hand valves. You want to let more natural gas into your furnace, you turn a valve. You want to let more air into your furnace, ammonia, whatever the gas might be, you would open a hand valve. and hope you got it right. We didn't have the feedback loop coming from an oxygen sensor. So early on, you just based it on empirical data, what the last load actually came out like. And then the intervention of circuit boards, software, computers, you had to apply all those things. And now all of a sudden we got closed loop control. So we started using an oxygen probe, which would measure oxygen. Then we could write an algorithm that would convert that to carbon potential. And from there, um, sensors came along as well for measuring dew point and infrared for three gas analysis. And now we're taking the latest steps into even moving more forward was sought for, and artificial intelligence. We're actually calculating soak times now based on what the feedback of the sensors are telling us. You might want to have a soak for 5 hours, but it's ready in 3 hours, and the system will actually change that for you. So it's
What,
come a long way, and the electronic controls were the key part of it.
back in the days, what were the biggest limitation of early furnace controls, and how did companies work around them?
Yeah, to me, the biggest limitation was just the apprehension. People didn't understand. You would use, I'll name drop a name, an Alnor device, where you could actually pull a sample in, look at the fog, decide based on some calculations and charts of where your dew point converted to carbon would be. Now all of a sudden you're trusting this electronic device tied to an oxygen sensor that nobody understood. And the limitation was just the new technology and getting people to actually grasp it. Other than that, really, it was cost. So there were some things early on, um, with an oxygen sensor tied to an electronic controller that would control process, but would not control the whole furnace. So if you had an automated furnace that would move a load from the vestibule to the heat chamber, back to the quench and out the door, um, those things were still hardwired, which meant that you had a lot of relay logic and people were landing wires. There was no PLCs involved. And the limitation of the electronics themselves, understanding how they would work, really created some apprehension with customers. Then, as time went by and people understood that and actually evaluated the sensor and the feedback and what could happen, cost and the apprehension of new technology went away.
And so, fast forward to today, what are some of the most exciting new capabilities that modern furnace controls bring to the table?
Yes. So now, to me, the controls themselves, when you look at a furnace, you're gonna have flow meters. You're gonna have the electronics in the device itself. You're gonna have the valves that really haven't changed over time, except for maybe some advantages in linearity. But to me, what I see going on right now is software. So not
Software.
only, yes, not only do you have a controller that will tell you the temperature, the percent carbon, things like that, but the software ingenuity that's come out that allows heat treaters to look at these furnaces and actually calculate cost per load and know why a furnace is actually down for some reason because somebody put input into it. So not only do you have the maintenance staff allowed to look at details for charting and things like that, but now the management team can actually look at and make decisions looking at the exact same data, just looking at it in a different format. So you might see a trend line on a chart that would help a maintenance guy know that a valve isn't open, but you can take that same trend line, turn it into a pie chart or a bar chart, feed it to the management team, and they can make decisions regarding how a furnace is in use. Is it sitting there idle? Does it need maintenance because something's broken? Does it need more parts? Maybe you just don't have enough input from components that are required to run your furnace. So to me, the big advantage today is the software on top of the hardware that allows you to excel more so than you've done in the past.
So it will be accurate to make this statement that if you upgrade your controllers, you're gonna improve besides process, productivity, efficiency, and even safety in the industry.
Yes, and we'll go one step further. You know, everybody talks about green now, your green footprint,
Right.
right? So yeah, so how much gas are you actually using? How much gas did you use on the last load? How do you know how much you're saving? And with all of the software compatibility issues with these sensors now, looking at infrared analysis to measure CO, CO2, CH4, measuring hydrogen and ferritic nitrocarburizing processes, all those things add up to actually reducing your footprint if you use it the right way, and also just better control overall.
So for commercial heat treats for companies that have had same controls that work, I mean, like the old UDC controls, they work. I mean, they just don't die, right? But they're very outdated. Uh, what that the companies might be considering an upgrade to their furnace control system. What would you recommend they to focus on? I mean, what they always miss besides cost, right? But when they come to you and ask you, I really want to upgrade my controls. My furnace runs well, but I have a customer that it has a little more quality special needs, or I really need to focus on this. What will you recommend them to stay focused on, or how to approach the project?
Yeah, so for me, you have to take a comprehensive effort to get that done because if you're going to upgrade your controls, what is your goal? Is your goal to meet a specification like AMS 2750? Is
Right.
it to meet 21 CFR Part 11 in the medical industry? What are you trying to accomplish? Is it just because you want a better interface? Those usually aren't the reasons to do that. If you're trying to meet a specification, then you have to take a holistic approach to the furnace. If you say, well, I can just replace the carbon controller and put something more modern in that has charting and things like that, that may not get you to where you want to be. You have to look at it and decide, what is the specification on my furnace? What is the specification the customer's requesting for me? And with the advantage of today's electronics, you can get tighter tolerances out of the same equipment. And it just comes down to the variability in the electronics or the actual controls you're offering. So to me, when you're looking at these kind of things, don't take a partial approach. Don't think about, well, if I just replace the temperature controller, or if I just replace the carbon controller, that can also turn into a support issue. Now you replace a carbon or temperature controller, but your PLC decides it's going to fail. So always look at it from a comprehensive goal rather than just limiting yourself to an improvement in one area.
Have you seen that most of the users in this market are metallurgists or materials engineer? And when you talk to them about complex electronics, how's the best way to approach that? I mean, you're talking to metallurgists or project guys that are very knowledgeable on steel, on transformation, but electronics is a totally different animal. What's been your
It,
experience working with the type of guys that are always focus on quenching, carbon potential, austenite, right? Distortion. And then you come and you start talking about PLCs and communications and Ethernet. What's can you share some input with that?
Yeah, so, and you kind of hit it on the head. Everybody has their own perspective of what they're trying to achieve when you update furnace controls. If you talk to the metallurgist, you're right. He's going to be worried about, how to reduce, retained austenite, whatever it may
Right,
be, right?
right.
So, um, getting all of those individuals in a room and drilling down to the details of what the actual rubber on the pavement, let's say, is going to accomplish. Because the metallurgist is they're all talking about the same thing, but they're talking about it through different sets of eyes, okay, and what they understand about the process. And I can tell you today, when I talk to the young men and women that are coming up in this industry, they have a better approach to how things are upgraded. They don't look at it from the pure metallurgy aspect. They also look at it when they'll ask the gentleman or the woman in the room that's from maintenance. They'll say, okay, you know, we're going to put this new mass flow meter on your incoming natural gas line. The next question is how we're going to maintain it. What kind of inventory does a supplier have? Those kind of things. So, getting your arms around the whole group of people that need to take advantage of these controls, and it is difficult. I agree with you there, but you have to drill down to the specifics for what you need. You know, a duplex thermocouple mounted through the sidewall of the furnace, that actually achieves a goal as well, rather than a single thermocouple mounted through, because you can never have enough data. The more data you have, the better decisions you'll make.
So can you walk us through a specific example, maybe a past installation or a project that you recall where modern controls provide a measurable benefits over traditional systems?
Yeah, I mean, some of the customers, and there's quite a few of customers that we're very proud to have worked with to create better controls. Um, I'll pick on belt furnace specifically. Belt furnaces typically for us in the past have been hard to get your arms around because they have a lot of moving parts, right? So with a belt furnace, you will need to not only control the carbon and the temperature, but you also need to control the product as it flows through the furnace. How do you achieve that goal? How do I take advantage of knowing that I can get a part started on the belt, a new part, while the old part is still in zone 3, zone 4 of the furnace moving out the back. So you have to take in consideration what we would call gap timing. That gap timing looks at a complex set of issues, the belt itself, the movement of the belt, the next load coming in, what the carbon potential has to be when it reaches soak, what the temperature should be. Those kind of variables, without the help of software, have in the past been very difficult to control, and the productivity out of the furnace, because you were manually changing those things, not looking ahead, trying to figure out when things can happen sooner. The belt furnace, in my mind, has been one of the furnaces that we've made great achievements on with very complex hardware and software to move productivity forward.
And now looking ahead, what trends do you see shaping the future of furnace controls?
Information.
Data, information.
Yeah, information is what I see shaping things for the future, because the data you pull from a furnace is looked at by everybody. I kind of brought that up earlier. So when you're looking at the data, the maintenance guy is trying to figure out when he needs to change a filter on a blower. The management team's trying to figure out if they need to buy a new furnace. The same data can achieve the goal for both parties, and you can never have too much data. So you need to know the gas you're flowing, the power you're using, the speed of the belt, the maintenance items when they need to be changed, tracking your carbon probes to know you can get the best life possible instead of just pulling them out at 12 months or whatever you're going to do. I see software changing the game overall. The furnace themselves, I don't make furnaces. We put controls on furnaces. I'm sure there's lots of, and you could teach me on that, Carlos, with Matza. You know, I'm sure there's lots of changes even in the furnace design that are moving things forward. But from my perspective, it's all about the software.
And the challenge with data, because I'm a big believer of data as well, but I see the challenge that we are getting flooded with data that we don't need. And I apply a lot the 80-20 principle. So, and I have seen a lot of big servers and big SCADA system gathering all kinds of data from big lines of furnaces. But they're very seldom customers or seldom users that do analyze data on a proactive way to forecast what's coming.
Yeah.
So most of the guys, myself included on my heat treat, when there's a problem, we go back to the data, right? What's your vision with software? And you even mentioned AI to start looking for a potential problem, to start looking for a potential deviation or process. Uh, any comments on that? I mean, because I do believe that that is coming from what we have seen on the other industries like the auto industry, the car industry, IoT. We haven't been as a market, as an industry, very fast to approach the IoT on furnaces, also because big corporations are very close with data and cybersecurity, which is a big issue for us to continue to grow. Do you have any comment on that?
To me, it's all about the visualization for the party that needs to look at the data. So if you had to spend your time looking at a chart, trying to figure out when something is going to fail or something has broken, that's all time consuming. People don't plan their day around that. But this is where the advantage is in my mind. With today's software, it allows you to have those reports printed for you. I can actually have that report telling me about, for instance, what is my specific need here? For instance, um, how many times has this furnace actually run a load above 1.2% carbon, which will cause, things to fail probably sooner than you think, just because of the carburizing aspect of the whole thing. Maybe you got to start thinking about when you got to buy alloy baskets, parts for the elevator, parts of the rails, name anything. But being proactive on the reporting side, so the software today can have waiting for you in your inbox a report that you can look at. You can be proactive. You don't have to go back and actually pull up a spreadsheet and start looking at things. And we can make this easy to visualize with bar graphs, with pie charts. All those things can be more looking forward than looking backward, if you get what I'm saying, because historically you're going to say, well, I have a problem in a furnace. Let's pull the chart from 3 weeks ago. And then you got to spend your time doing that. But if I know that I put a blower on a furnace a year and a half ago, and the software is counting the amount of hours and rotations it's run, I can plan to have that blower replaced at a certain time. And I can look at that ahead of time and know that. Hopefully that
Are there
answers.
any? You did. And are there any exciting projects or R&D initiatives at Super Systems that are pushing the envelope in the furnace controls? I mean, you just showed your SuperGen, that it's a beauty, state of the art, looks fantastic, right? What's next?
What's next for us is just looking at overall the green effort that everybody's trying to achieve. We have some tools in our tool belt that we've had for quite a while that we feel we're making better. And so, for instance, with the SuperGen, the ability to possibly have a control system that a customer can install and reduce the complexity overall without having one of our engineers on site. So it's going to reduce cost as well. So we're trying to reduce the complexity on what it takes to install a modern system. We're looking at the software, which I keep talking about, that allows the operator, the owner of the company to make decisions on where the company's heading. Flow meters, looking at flow meters, other industries use mass flow technology frequently. We're incorporating mass flow into our flow meters for the thermal processing industry. And those mass flow technologies not only are going to enhance the tolerances, but possibly even move forward the productivity of the heat treat. So there's, with flow, with control of endothermic gas, with the new matrix you brought up earlier today, allowing us to build a modular type control system that you can expand on as needed. All those things are what we're doing to move the foundation for our industry forward. And then on top of that, we have a lot of young guys coming into SSI now too. And those young guys, bring new technology with them, that they've learned throughout their career in college or whatever they're doing, where their exposure was. So, yeah, I'm really looking forward to see where the younger generation brings us.
Bob, you talk about the newer generation, and I always like to ask the guys that come to the podcast this question. We talk very technically, but you've been in the industry around. Uh, you have a very successful career. You're a very well-known individual, but you started one day, maybe 30, 40 years ago. I don't know. If you were to travel back on time, what will be an advice that you will give to your younger self, or what will be an advice that you can give to the younger generation that are entering the heat treat industry, right? I do believe that this industry is losing its talent faster than it's getting it, right? But this industry is very unique, it's very technical, very challenging, and if you get into some point, it's very passionate, right? But I do believe that we're not doing a good job promoting how beautiful our industry is. Do you have any comments for the new generations of heat treat engineers?
The comments I would make overall is they come out of college and they know a lot. I mean, these guys with the technology available today, they start way ahead of where I started because they already have a grasp for the technology that's out there. The one piece of the puzzle I feel they're losing is not knowing historically how to build on that technology. So my advice would be to actually grab a mentor, grab somebody and trust somebody that's been in the industry that you respect and reach out to them and use their knowledge to enhance your knowledge. That is going to get you a long way because the older guys have a lot to offer, and learning from their mistakes, just like history with anything else, right? You learn from mistakes from the past. So a mentor to me is a big goal that I would have had, and I would have done a better job. I've had some, I mentioned them early on, but did I spend enough time trying to pick their brain to learn from them? I think that would be something that I would have done differently.
Thank you, Bob, for sharing your insight with us. It's been fascinating to see how far furnace control and technology has come and where is it heading. Any last thought? Any last thoughts for our listeners?
No, just embrace the industry. Go out and learn, join different, like for instance, I'm a member of ASM, I'm a member of IHEA, I'm a member of MTI. All those things you learn from, and expose yourself to the industry because it will give you benefits in return for, the exposure that you offer and how you open yourself up to others.
So thank you, Bob. Thank you. Thanks for our audience for tuning in. If you're interested in learning more about furnace controls, or if you have a need, be sure to check out Super Systems Sync and stay tuned for more episodes. Until next time, thank you so much, Bob.